this computer. Okay, so here we are. We're going to do a review for test 1. You can break in and ask any questions you have. These are the topics we're going to cover. The average rate of change, instantaneous rate of change by calculating a limit, estimating slope of a tangent line, and will be another technique we'll talk about. Noah, you talked about graphing rational functions. We'll cover that. And then we're going to be talking a lot about how to calculate limits. And there are various ways to do it, and they're sort of listed here. And then the last thing we're going to talk about is continuity. Now, the average rate of change. This is something that you had in college algebra, I'm sure. It's really like you go on a trip and you start out at a certain time and end at a certain time. There's the length of time you take, which is the change in the time. And then you look at how far you went and divide that by the time, and that's your average rate of change. And so the average rate of change is the ending y2 minus the beginning y1 divided by the ending x2 minus the ending x1. A very simple problem here is if you have f of x is equal to 10x cubed plus 10, we want average rate of change over the interval minus 4 to 4. So we can simply write down the average rate of change is equal to, we plug in 4, and we get 10 times 4 cubed plus 10. Then we subtract off the value at minus 4, which is 10 times minus 4 cubed plus 10, all divided by 4 minus 4. And this is equal to, first of all, we have plus 10 and minus 10. We'll cancel out, and then we'll get 10 times 4 cubed is 640. Minus 4 cubed.
Wouldn't it be 650?
No. What's 4 cubed is 64 times 10 is 640.
Oh, okay.
And then, of course, minus 4 cubed times 10 is going to be minus 640. So we have minus is plus 640. And then the numerator is 8. So this is 1280 divided by 8, which is 160. So the average rate of change is 160. Any questions? Now, calculus, at least differential calculus, calculates the instantaneous rate of change. So if you're going down the road from here to Atlanta, you're not going to go the same rate all the time. You're going to change your speed to go around somebody or slow down. And so it will not be a straight line. You might go from here to Atlanta, maybe something like this. And here we want to figure out the instantaneous rate of change at any time. And you look at your speedometer, and by the way, it's doing calculus for you. It's calculating the instantaneous rate of change of your car at that time. It's also we would call this the slope of the tangent line. So if you are right here, think of a line that just touches the curve at one point. The slope of that will give you an exact indication of how fast you're going. Notice if you look right here, slope of the tangent line would look like that. That slope is larger than this slope, and so you're going a lot faster. Okay, to calculate it, you take the function and evaluate it at f of x, and then go just to the right of x by the amount h, and let h go to 0, and that gives you the slope of the tangent line. If this, you want to calculate the limit. Okay, so let's do an example. We have a function here, y equal -2 minus 8x squared, and we want to calculate the slope at the point -3 and -74. Okay, we will need this equation, and for this one we're going to do it for any x. Okay, if you wanted to do it just for -3, you would just plug in -3. But if you want to do it for any value of x and then plug in the value of x, I always find that the easiest thing to do. So let's do that. F of x plus h is equal to -2 minus 8 times x plus h quantity squared. So let's now calculate m, which is going to be f of x plus h. It's going to be the limit as h approaches 0 of -2 minus 8 times x plus h quantity squared. And now we need to subtract off f of x, which is -2 minus 8x squared divided by h. Now we need to multiply this out. And it would be -2 minus 8. We need to square x plus h, which would be x squared plus 2xh plus h squared. And now we need to subtract this off, and this will be -2, which will be +2, minus 8x squared, which will be +8x squared, all divided by h. And continue to simplify this. Notice, first of all, 2 and -2 will cancel. And we're going to have -8x squared minus 16xh minus 8h squared plus 8x squared divided by h. Notice this cancels. And we're left with, notice we can factor an h out of each of these two terms. So that's going to be limit as h approaches 0. Take h out, and I've got -16x minus 8h, all divided by h. And this will always happen if you can calculate the limit. You will get h to cancel out, which gets rid of dividing by 0. Now you plug in h equals 0. And notice that this slope is now minus 16x because h is going to 0. So the slope at x equal minus 3 is equal to minus 16 times minus 3 equal 48. So the slope of the tangent line is 48. So we know that the equation of the tangent line will be y equal 48x. Well, let me 48x plus b. And we need to find out what b is, and it must go through the point minus 3 and minus 74. So to make it do that, plug in minus 74 for y equal 48. I'm sorry, this is y equal 48, x plus b. So it would be 48 times minus 3 plus b, and you'll see that b then equals, this is minus 144. So putting it on the other side, we get b equal 144 minus 74, and b equals 70. So now we have the full equation of y equal 48x plus 70. And that is the answer for the slope of the tangent line. Now, sometime you may be given some data. You might be given these points and you might plot them. And you might be asked to estimate the slope of the tangent line. Well, what I would do is just put sort of a curve through there. This is not a beautiful smooth curve, but it gives you an idea of what the graph looks like. And if we wanted to figure out the slope at the point A, we would sort of draw in a tangent line, and that's about what it would look like, and its slope would be 0. Now, let's look at B. Here, I'm not a great artist, but I would say the slope, the tangent line would look at something like that. And drawing this, you could figure this point is 3, this point is 1. So the change in the y, the rise is 2, and the change in the x is 1. So the slope at B would be 2. So that's a good estimate of the instantaneous rate of change. And so now let's go look at C. I'm drawing a very crude tangent line there. And the drop is -1/2 if you look at the scale. And the change in x is 1. So m, slope at c, would be -1/2 divided by 1 equal -1/2. Obviously, the slope is negative, it's going down, and it's going down slower than it's going up right here. Anybody got any questions?
Not yet.
Now, I think we've said that a lot of functions, all you need to do to calculate the limit is just plug it in, just substitute for the value of x. Notice in this particular function, we're not dividing by 0. There's nothing crazy going on. So you just plug in, and that limit is going to be 14 minus 6 times -2 plus -2 cubed. That's 14 plus 12. -2 cubed is -8. So this will be 18. And then for the second one, plug in 10. You get 4 times 10 plus the cube root of 10 minus 2. That would be 40 plus the cube root of 8, which is 2. So that's 42. Okay, Brandon Browder is asking you to come in. I'll admit him. Brandon, are you there? Brandon?
Yes, sir.
Okay, we've already started, so you can watch the video. I'm assuming you're in.
Yes, sir.
Now, one of the things, you can estimate limits from tables. Suppose you had a function and you were trying to find the limit of f of x as x approaches 5, and you put it in your calculator and generated a table, and if you plug in 5, it says it's undefined. Probably it's trying to divide by 0. But what you can do is create a table around x equal 5. For instance, we've got 4.9, 4.99, 4.999, and on the right side, we got 5.001, 5.01, and 5.1. Look at the values that the calculator calculates, and you would guess it looks getting closer and closer to 75. So we conclude that the limit is 75. Does everybody know how to generate a table on the calculator?
I do. I don't know if everybody else does.
Would you like, I may do that for this particular problem. But first of all,
How do you know like when to put, so I always have it set up as like 0.97 to 0.01. How do you know when to make it like 5.97?
You sort of look at what you're getting and try to figure out if you're making it the increment small enough. I'm going to work this by just factoring first, and then we'll generate this, okay? Notice if you plug in 6, you'll get 0 in the numerator and the denominator. And you can't divide by 0, but the limit could still exist. And what you do is try to factor. Notice the denominator can be factored into t minus 6, t plus 6. And the numerator, t plus 9, t minus 6. And the nice thing that happens is you can cancel out the t minus 6, and now your divide by 0 problem has gone away. So now you plug in 6 and 6 and get 15 twelfths, which is equal to 5 fourths, which is also equal to 1.25. Now, let me pull up the calculator. But I think I've got the calculator on here. I'm going to put that in the, this is just another way you can check it. I'm going to put x squared plus 3x minus 54. I want to divide that. Be sure and use parentheses. Divide by x squared or t squared minus 36. And we are interested in the value around 6. So let's go here to table set. You hit second table set. And you put in where you want to start the table. Well, I want to be close to 6. And so let's start at 5.95, okay? And delta table is the increment. I'm just going to pick 0.01, okay? And now I'm going to generate the table by hitting second graph. So here's our table. At 5.95, y is about 1.251. As you keep on getting closer and closer to 5, in fact, at 5.99, it's 1.25. And of course, it gives you error there. And you go on the other side to 601, it's 1.2498. And so a very educated guess is that the limit of this is 125. This is a way to check your work, folks, if you're not sure you did this right. Obviously, the fastest thing is for this particular one is to factor. Everybody agree to that?
I got 36 on my table.
36.
Mm-hmm.
Well, I really can't see what you did with your calculator, but did you plug in the function like this?
X squared plus 3x minus 54 divided by x squared minus 36. I didn't put the second part in parentheses.
That is a killer if you do not use parentheses.
Yes.
It will, so just come back and look at the video and get it correct, okay? And
Yes.
then you will generate one just like this.
I see it now. Got it. Thank
Okay,
you.
good. Now, finding limit with radicals. Notice you got a radical here. And notice if you plug in x equal minus 11, you'll get 0 in the denominator. And so you got a problem. Turns out that if it's set up like this, very often you can multiply the numerator and the denominator by the conjugate, the radical conjugate. So let's set this up like this. We're going to just write down what we see. And then we're going to multiply it by the radical conjugate, which will be 10 plus the radical. If that was radical minus 10, you would do it radical plus 10, okay? But anyway, we're going to do 10 plus the radical. And x plus 11. And always remember to multiply the denominator by the same factor. And now, the way we've done this is going to make it easy. Limit is x approach minus 11. Now we're going to just do, you FOIL it now. So the first is going to be 10 times 10, which is 100. And now without writing the outside and the inside, just look, you're going to have the outside is going to be 10 times the radical. The inside is going to be minus 10 times the radical, and they will always cancel out, okay? So I don't have to write that down. And the last is going to be minus the radical times the radical, which will take the radical off. So we'll write down x squared minus 21. Divided by, we still have to write this down. Just be careful. And if I make a mistake, let me know. So now we've got the limit as x approaches minus 11. And notice we've got 100 minus x squared minus 21. So that'll be 121 minus x squared divided by x plus 11. 10 plus the radical. Just got to be careful. Now notice, this looks like x squared minus 121, except it's the negative of it. So that's minus x squared minus 21 divided by x plus 11, 10 plus the square root of x squared minus 21. And now we're going to have to factor again. This is getting a little more involved, but it's all going to fall out. X squared minus 1, I'm sorry, this is 121. So x squared minus 121 is x plus 11 times x minus 11. Now we're seeing some light at the end of the tunnel. And now you factor the x plus 11 out. That gets rid of the problem of dividing by 0. And now you plug in minus 11. And then you get minus 11 is minus 22 times minus 1 is plus 22. So it's 22 over 10 plus 10 plus the square root, plug 11 in here, which is 121, minus 21 gives you 100. So we got nice numbers. You get 22 divided by 10. Plus, excuse me, I don't need this extra 10 here. You see my mistake? This canceled out, that canceled out. We got 10 plus the square root of 100, which is 10 plus 10. So it's 22 over 20, which is equal to 11 over 10. All I can say is always check your work. You can be going along at a pretty good pace and look back and see you wrote something down right, which is something down wrong, which is what I did right here. Now, I want to erase some of this so I can have some room to work the last problem, the next problem. I wish there were a button to just erase the entire thing. One way is almost, it's just to load the file again and it'll be clean. Okay, I think I've got enough room to work. The next one is not going to be as involved. Use the same techniques. We've got a radical here. So we want to write the limit as x approaches 0 of 3 minus square root of x squared plus 9. And we want to multiply it times a radical conjugate, which would be 3 plus the square root of x squared plus 9. Write the numerator down and remember to multiply write the denominator down and then write in the denominator the same radical conjugate. And now multiply this out and you get 3 times 3 is 9. 3 times the radical minus 3 times the radical gives you 0. And then you get minus the radical times the radical, which takes the radical away. And you got x squared times 3 plus the square root of x squared plus 9. And now we've got 9 minus 9, which is 0. And we're left with the minus x squared. So we get the minus x squared over x squared times 3 plus the square root of x squared plus 9. And we're taking the limit as x approaches 0. And notice the nice thing that happens here, the x squareds cancel and we get the limit of minus 1 over 3 plus the square root of x squared plus 9 as x approaches 0. Gives us minus 1 over 3. Plug in 0, we get the square root of 9, which is 3. And we get minus 1/6. So the answer is minus 1/6. Now I do have one more radical one to do. Does anybody want to see this? Let's do it. Okay. It's going to be the same technique. The limit as t approaches minus 1. of 2 minus the square root of t squared plus 3 divided by t plus 1. Now we multiply by the radical conjugate. And do the same to the denominator. What you do to the top, you got to do to the bottom. And now we multiply this out. And the nice part about it is you're always going to get things to drop out and go to 0. 2 times 2 is 4. We have 2 times the radical minus 2 times the radical gives you 0. And then we have minus the radical times the radical, which leaves just what's under the radical. Now, that's 4 minus t squared minus 3. That's going to give you, by the way, this is minus 1. Always check your work. 4 minus 3 is 1, so that's 1 minus t squared divided by t plus 1 times 2 plus the square root of t squared plus 3. And notice this looks like t squared minus 1, except it's a negative of it. So that's minus t squared minus 1. So let's factor that into t minus 1, t plus 1, divided by t plus 1 times the radical expression. Sometimes I go too fast and write it down wrong. That's why I watch every step. Notice the problem goes away when we factor or cancel t plus 1 and t plus 1, and then plug in minus 1 for t. That's minus 1 is minus 2 times minus 1 is plus 2. And down here we plug in 2 plus the square root of minus 1 squared plus 3, which equals 2 over 2. Minus 1 squared is 1, plus 3 is 4, so it's 2 plus the square root of 4 equal 2 over 4 equal 1/2. So the limit is 1/2. Anybody got any questions?
No,
Everybody still there?
No, sir.
Okay. That was a lot of radical stuff. Now we're going to switch to finding limits by analyzing graphs. So look at this graph, and it's got a lot of discontinuities. And what we're going to do is calculate some limits. Okay. Let me, first of all, this point over here is going to be 3.5. That sort of lines up with that point there. let's start with 4. And let's look at the limit as x approaches 4 from the right. Okay. So to find the limit as x approaches 4 from the right, you need to start from the right. So let's hop on the curve, say here, and then follow it up curve, continuing to get closer to x equal 4. And what does it look like the limit is going to?
To the
Anybody got an idea?
say it again, sir.
What does it look like the limit from going from the towards 4 from the right?
To the infinity.
Exactly right. So that's an infinite limit. Okay. Now, some of the graphs you can actually graph on your calculator and see the vertical asymptote. Okay. Now, we're going to calculate the limit as x approaches 4 from the left. Okay. Anybody got any idea what that is? We hop on the curve, say right here, and go on the curve and get as close to 4 as we can.
-2.
What's the limit?
-2.
Exactly right. Now, what is the answer to the question? What is the limit as x approaches 4, irrespective of side?
It does not exist.
Exactly right. By the way, notice f of x should be right here. Does not exist. Okay. Well, that takes care of 4. Let me erase a little bit.
When you erase, have you tried circling everything and pressing in the middle?
It doesn't work with this particular app.
Oh, okay.
There are some, now I like this particular way of getting you the notes, and I'm just writing on a PDF file.
Oh, okay.
And I tell you, you can see what I've got here. You see, I can draw. See right here?
Yes, sir.
And then I can highlight it, and then I can erase it. What this thing is missing is, well, one thing is a go back button, so that if I wrote something and made a mistake, I'd like to just erase it by pushing something. But then I got to go over here, hit erase, and do that. See?
Oh, okay.
If I were designing this app, I would put some other features on it. By the way, with Zoom, there is another ability to do a whiteboard, but it's sort of tricky too. So anyway, let's do point -1. The limit f of x as x approaches -1 from the right. What is that? Hop on the curve from the right and go towards x equal -1. What is y? It's -2, isn't it? And now we'll do the limit of f of x. X approaches -1 from the left. So let's go to the left of -1 on the curve, and we'll keep getting closer and closer to x equal -1. And it looks like it's limiting going to -1. Now notice the hole that's not filled up means that point is not there. The hole that's filled up means that point is there. Okay. So another thing we can say about this graph is that f at -1 is equal to -2. We could also say that the limit of f of x as x approaches -1 does not exist because the right and the left do not agree. Let's see. See if we got enough room. That's right over here. Let's take the limit as x approaches -2. Of f of x. Now I'm going to ask you another question. I'm not talking about the right or the left. I'm saying as x approaches -2, what does the limit equal to?
For which one?
For -2. As x approaches -2.
3.5.
Very good. Exactly right. Because let's go from the left. You go from the left, it's getting closer to 3.5. You go from the right, it's getting closer to 3.5. And so the right and the left agree, so this is true. However, f of -2 is what?
3.5.
What's the value of f at -2?
3.5.
Remember, that means if it's not filled in, that point is not on the graph.
Oh.
F of -2 is not 3.5. Where is the dot lurking down there that tells you what the value is?
The red one. 0.
It's 0. So f of -2 is 0. So this tells you that the value of the function at that point does not have to be the limit as x approaches -2. We saw that the limit is 3.5, but the value of the function is 0. Now, if I decided to change this graph and said, forget about that, we're going to fill this in. Now the function at -2 is equal to 3.5. Now the last part of this, I think I've got some room down here. Let's look at the limit of f of x as x approaches -5. Now, obviously, there's a disconnect here. Let's come in from the left. What is that going to be? Hop on the curve.
-3.
Negative what now?
3.
We're headed towards -5 now.
Oh, up. Sorry, 2.
2. That's good. Just always check your work and then limit of f of x approaches -5 from the right is what?
-3.
-3. As you get on the curve and you follow, keep going until x gets closer to -5 and you're going to -3. Wow, takes time, doesn't it? This is a whole lot of these graphs. Now, I've already filled in a couple of these. As x approaches 4, the limit is 8, and everything is good from the right and the left, so you don't have to worry about a right and a left. Now, x approaches -3 is 6, because look, at x equal -3, it's just a straight line and there's no hole in the graph or anything. It's not doing anything crazy. So it's 6. What is the limit as x approaches 0?
-1.
Think about that. X is approaching 0.
It does not exist.
Here's x equals 0, right? That point's not on the graph. But anyway, coming from the right, it's approaching a certain number. But coming from the left, it's approaching another number. So what's the answer to the limit as x approaches 0?
It doesn't exist.
Exactly. Does not exist. Always ask, do the right and the left agree? Now we can answer the question, as x approaches 0 from the left, it looks like it's what?
-2.
-2. And as it comes from the right,
-1.
-1. What is alpha -2?
2.
Okay. Look at it a little more carefully.
8.
Yes,
Oh.
that's right, because that dot is way up here, okay? And the holes in the graph here and here, but yet the limit, as it approaches 2 from the left, is what?
6.
6. And approaches, oh, this may be a typo here. Approaches minus, no, that's right, approaches -2 from the right.
It's 2.
It's going to be 2. Okay. Now, I think you guys have got it right now. I'm just going to, let's do the limit of f of x as x approaches -2 from the left is equal to what?
-4.
-4, which also is equal to the limit of f of x as x approaches -2 from the right, equal -4. F of -2, though, is equal to, there's a hole down here, is equal to 3. So we know that the value of the function at a certain point doesn't necessarily have to be the limit as x approaches that value. And we can do the limit as x approaches 4 from the right is equal to 6, and the limit of f of x as x approaches 4 from the left. Hop on it, and you'll see that it's equal to 4. By the same token, as you go towards 1, you either from the left go to 0, or from the right go to 2. Now, an important point about limits we just mentioned, the limit of f of x as x approaches a point C can be equal to L. That L limit can exist even if f of C is not equal to L or it's not defined. So a case in point, we just saw the limit here was going to be 4, but f at minus 2 was 3, was not equal to the limit. Okay. The limit of f of x as x approaches 0 from the left is what?
Can you repeat that, please?
Okay. It seems like now it's moving. For a minute there, it froze up. Well, it's still a little frozen. Okay. My pen is stopped. Now there it goes. Let's do f of x, x approaches 0 from the left. This equals 0.
0.
From the right, it's 2. Does not exist for this one. The right and the left are not the same. Going to 2, 2 from the left, minus 2. 2 from the right is 0, but then the overall thing does not exist. And then finally, 4, the right and the left is going to be 4. And the overall limit is 4, even though there's a hole in the graph. Now here is a function that's a piecewise function. I've drawn it right here. It's defined depending on what the value of x is. The limit as x approaches minus 6, just read it off as 31. The limit as f of x approaches 1 is going to be 31. I'm sorry, it's going is going to be 3. That's because the left and the right limits are equal. And finally, we have a function that has a discontinuity. It's defined this way. Think of the 6z, if z is less than or equal to -4, the 1 not minus 9z if z is more than -4. So the limit as z approaches 7, 7 is more than -4, so you would use this definition. So that limit would be 1 minus 9 times 7 is equal to -62. Now the limit as z approaches -4, what would be the answer to that?
Negative. Oh,
Think about it. The limit, it didn't say from the right or the left. What would you say?
38, 37.
What's another answer that's okay to say?
Negative 24.
No, the answer is it doesn't exist.
Oh, all right.
Okay, you come in from the right, it's going to be 37. You come in from the left, it's going to be -24. So it does not exist. Now limits as x approaches infinity. As x approaches infinity, looking at things with polynomials in them, you got to realize that the polynomial with the highest degree dominates as x gets large. So this equals the limit as x approaches infinity. I would write down 5x squared dominates. Here, 3x squared dominates. So the answer is 5/3. Similarly, for this one, 4x squared dominates the -1, so you got the square root of 4x squared divided by the dominating one here is 2x. So that's equal to 4x squared over 2x, excuse me, is equal to 2x. Let me erase this. Is equal to 2x over 2x. And there was a minus in front of it. So the answer is -1. Now, calculating infinite limits using a graphing calculator. This is a rational function. You graph it on your calculator. Does everybody know how to put this in your calculator?
No, sir.
Okay. What you see on the right here is the graph. I'm going to bring the calculator up. But there will be graphing some rational functions and interpreting them. I'm going to put 2x squared divided by, remember the parentheses now.
Yes.
Minus x squared. Excuse me. Getting late. Let me clear this. Trying to get rid of that. Okay. 2x squared. It's getting late tonight. 2x squared divided by parentheses 4 minus x 1 squared in parentheses. And we want to graph this, okay? You can see there's going to be something happening at x equal 2, right? That's where the denominator is going to be 0. So I'm going to zoom to the standard window, zoom 6. Come on. Okay. Zoom to the standard window. And see the graph?
Yes, sir.
Now here is 2. And notice I have sort of copied and blown up this graph. And so we have these dotted lines or the vertical asymptotes. Now, how do you calculate these limits? First of all, the limit is x approaches 2 on the right. Let's hop on the curve over here and ride the curve down as x gets closer to 2. We know it's going to minus infinity, right? And then let's hop on the curve as x approaches 2 from the left. That means I get on here and I go up to plus infinity. Now on the other side, let's x go towards minus 2 on the right. So I hop on here and I go to plus infinity. From the left, it's minus infinity. Does that make sense?
Yes, sir.
Okay. So most of all, remember to graph it carefully. Now, the last thing we're going to talk about is pretty simple, continuity. A continuous graph does not have any abrupt changes in value. It's discontinuous if it does have abrupt changes. This is a perfectly continuous function. It has no breaks in it, no jumps. It's nice, smooth curve. In fact, it's a polynomial expression. We're going to be looking at graphs. This graph, you might be asked, is it continuous or discontinuous? It's continuous. No breaks. In fact, it keeps going up that way, goes down this way. This graph is continuous. It does not have any gaps or jumps. It does change directions, but it's continuous. What about this one?
No.
It's not, it's got a discontinuity right here. There's a big gap in the two curves. So it's discontinuous at x equals 3. This is what?
No.
Okay, it's discontinuous here. And discontinuous at minus 3. Discontinuous just because it has this hole here and has its value at minus 1 and 3. That's discontinuous. Other than that, it's pretty smooth, okay? Except if you could put this point down there. It's discontinuous here only because it's got a hole there, okay?
So if they have holes, they're discontinuous?
Absolutely, remember that, okay?
Yes, sir.
Because you're going along on this curve, it's all the points are there. All of a sudden, you get very close to 2, and you know that the point 2 and 1 is not on the graph. In fact, it's not defined. Now we just put a nice little point here. It's continuous there. But this overall graph is discontinuous in several places. And you may be asked to decide that. Discontinuous, discontinuous. Here is another example, the square root of x squared minus 2x. It's continuous over here, it's continuous over here, but it's not defined in between. So there's a big gap between 0 and 2. And that's because x squared minus 2x is negative, and you can't take the square root of it between 0 and 2. So that's continuity. Does anybody have any questions? That's basically it.
No, sir.
Okay. I wish you all luck. Get in contact with me if you have any questions. Be ready to take the test on Thursday and Friday. Look at the chart that I sent out, and I wish you the very best on the test.
I have one question. Are we going to be able to use the calculator on the whole test?
Yes.
Awesome.
Absolutely. You will use the entire calculator. I'm going to stop the share, and I wish you luck. Oh, Brandon, how you doing? Since I had the my screen up, I didn't see you. Are you doing okay?
Yes, sir.
Okay. Give me a call anytime anybody has any questions, okay? Yasmin, you take
Yes,
care.
Say it again, sir.
I said, take care.
Thank you.
I'm gonna go to, well, I'm not going to go to bed in a minute. It's just 8 something. But you guys take care.
Thank you. Have a good night.
Have a good
Bye-bye.